Okay, this is the first example. This is a recursive sequence. We have no explicit formula to apply the limit. Therefore, we apply the monotonic conversion theorem. No? I need to prove this monotonic unbounded. Therefore, I use a spreadsheet Excel. Okay, I type in 1, 2, 3, 4, 5, the natural number. I type in the equation. The equation is this equation. This equation is 3 minus 1 over b, b3 in this case, and super fast converge. You can see that the sequence is bounded and also it's monotonic, and the answer is this value. Okay, if the limit exists, you can set up like that. L is the limit. That is supposed to be limited when the n approaches to infinity. A sub m is equal L. This is n or m plus 1, it doesn't matter. This is 3 minus 1 over L, and you're solving this equation. Multiply everything by L. L squared is equal to 3L minus 1. L squared minus 3L plus 1 equal to 0. You solve the quadratic equation using the quadratic formula maybe. Minus b is 3 plus or minus square root. B squared is 9 minus 4 multiplication by 1 multiplication by 1 is 4 divided by 2. The answer is 3 plus and minus radical 5 over 2. Let me use the calculator now. So the equation is the equation is x squared minus 3x plus 1 equal to 0. Solve this equation. Solve this equation with respect to the x back. Okay, there you go. This is the answer. And the decimal approximation is, look at that. Decimal approximation is 2.61803. 2.61803 is one value, and another value is, let's see the calculator, 0.38. 38 what? 1966. 1966. It's obvious that this value, no. But this value is the answer. So this is a limit. Exactly the same we did in the spreadsheet Excel. Okay. This is the second example of the recursive sequence. Again, we go back to the spreadsheet Excel. Okay, the sequence is monotonic and also bounded. Now the limit exists. And the limit when the n approaches to infinity of a sub m is equal to L. But I don't know what the value of L. L is equal 1 over 3 minus L. You apply now cross multiplication. This is 3L minus L squared equal 1. No? Let me set out the quadratic equation. L squared minus 3L plus 1 equal to 0. This is exactly the same quadratic equation that we solved the last time. The answer is 3 plus or minus radical 5 over 2. So remember, this value is 3 plus radical 5 over 2 is approximately in decimal 2.61803, and 3 minus radical 5 over 2 is approximately 0.38 196, and this is the value for the limit in this case. According to the spreadsheet Excel, you can see at what value converges. Okay, this is similar. Converge too fast is, 1 to 23 element, and you can see get monotonic and bounded because this stays the same, right? And the answer I want to find is this answer. Use the limit. This is example 3 of the recursive sequence. I need to prove case monotonic and bounded. Therefore, I use it one more time. Spreadsheet Excel. Okay, again I put a 23 turn of the sequence. You can see that this converges faster than this. Is the value que converge is radical 2, the 1.41, 4214. Okay. So the sequence is monotonic and this is bounded is because the conclusion is delimited. And the n approaches to infinity, a sub n plus 1 equal L. N plus 1 or n, doesn't matter. Entonces L is equal 1 plus 1 over 1 plus L. Okay, multiplication everything by 1 plus L. L times 1 plus L is equal 1 plus L plus 1. This is 2 plus L. This is L plus L squared minus 2 minus L equal to 0. This L is cancelled, the equation is L squared minus 2 equal to 0. And it's super easy. L squared equal 2, square root both sides. L is equal plus or minus radical 2. But the negative solution is no good. Only the solution is positive, square root 2. Okay, this is the sequence convergent and convergent to that value. Super fantastic.